Okay. So today we're going to be looking at tangent line problems, looking at some little harder topics. And our first one for this type of a question is a little bit trickier. So what we need to do before we can differentiate is we've got to expand those brackets. We're going to expand by multiplying through by this x squared term to each of the three terms inside. X squared times x squared over 4. Just ignore the numbers in the bottom so that we do x squared times x squared, giving us that over 4. X squared times negative 1 is going to give us x squared. And x squared times 2 over x squared is going to look like this. We're going to get 2x squared over x squared, but you then have to cancel through like this. So when we're finding the derivative now, we're differentiating, and we're going to get 4x to the 3 over 4 minus 2x. And then this last term is going to be just simply simplifying down to 2, so it won't differentiate. Simplifying that, we're going to get x cubed minus 2x. Okay, I'm going to pause for a few minutes, give you 5 minutes, have a go at those problems. The next one. All right, so when we expand the brackets, we multiply numerators and we multiply denominators. This first one is going to be ax squared over 2x. This next one's going to be ax to the 5. When you multiply x squared by x cubed, you add the exponents. In the denominator, we'll get 2 times 3, and that's going to give us 6. Before we differentiate, we simplify. That x cancels one of those. So then the derivative is going to be, we have a over 2, so we could just write it like this, a over 2x minus 1 over 6x to the 5. So the constants can be separated out like that if you want. So this last one, this first one is going to be a over, let me make my a look like an a over 2. Whereas this other one is going to be minus 5 over 6x to the 4. Have a go at this last one now. All right, so looking at this last one here now. So we need to expand. We've got 1 times x cubed. We've got 2 times x. We've got 1 times 5, and then an x on the bottom. We've got 1 times negative k, so we get k over x squared. Simplifying, this x will cancel one of those down to a 2. We might want to rewrite this one in exponent form. So we've got a half x to the minus 2. Sorry, we've got a half x to the 2 plus 5x to the minus 1 minus kx to the negative 2. Notice how I'm showing when I'm switching from the function to the derivative by using the correct notation. So 2 times a half, that's 1. This is going to be x. This is going to be minus 5 over x squared. This is going to be plus 2k over x cubed. All right, get your calculators out, get your calculators in your hand, get them ready. I would say that these type of derivatives, sorry, let me show it on the video. These type of derivative expressions would be expected of a student aiming at a 7. So I'm covering this. This isn't necessarily for everybody. Often on a question like this, for those of you who are aiming for a 5 or so, you might get part A has asked you to show that the derivative is equal to this, so that you then can continue the rest of the question yourself. These are the top end level skills expected on this course of a student at a 7. Okay, so our next problem is to differentiate this. So I'd like you to have a go at finding the derivative. This is super easy, this one. Use your calculator to find your derivative value. Use your calculator to find the derivative of this expression. Obviously, we have a much more complicated expression in the denominator, which means we can't differentiate in this using our rules. So we're just going to use the calculator and practice that technique again. Let me give you 2 minutes for that, just to get set up while I pause the video. Okay, follow me along on your calculator. So let's always start off with a new page. Let's add a calculator page. We can do calculations here. For typing in a function like this one, I generally recommend typing it in into the graphing part, especially if we're going to use it a few times. I like to type it in here. So we want control divide, and then we can type 2x minus x squared over 3 minus x. Then move back to your calculator screen. Notice you see it says there cat. Control shift switches that off. Yours looks no. So then what we're going to do, once we've typed it in, move back to your calculator page, press menu, calculus, numerical derivative at a point. The point that we want to calculate for is 2.3. And then we insert the function by pressing the variables button. We want f1 of x. So we put f1 and put it on the domain of x.
Wait, so the variable is x and then the value is 2.3.
And this gives us our answer. So f dash of 2.3 is equal to negative 5.12. Here is our answer. Okay, so here we have a question. We're going to consider the function f of x is equal to x cubed, and we wish to find the derivative of that. So our first one is going to be f dash of x is equal to 3x squared over 3 minus 8x plus 3. And then this will simplify down to x cubed minus 8x plus 3. Okay, have a go at part B now. Pause the video. All right, sorry, we can continue. So we're told here in the question that we have a curve and we have a line. This line is a tangent to the curve. So even if you could sketch the curve and you can sketch the line if you want to, but I'm not going to sketch the curve correctly. We've basically got one of these type of problems. We're told this. It tells us that line 2 is parallel to the curve. Sorry, there's our tangent. It tells us that line 2 is parallel to the curve, to the line L1, and it's also tangent to the curve. What that means is this line L1 and this line L2 have to have the same gradient. and then they're going to touch the curve at different points. So this is a problem-solving question. We haven't seen a problem-solving question before, and these are always going to be unique situations, but it comes from an understanding of what everything means. So for line 1, what is the gradient of line 1? What is the gradient of line 1? How do you get that? Look at this line here. It's quite a simple looking line. We're told in B that y equals, I'll write it as y minus 3x equals 0. If you rearrange that, it tells you that y equals 3x. So that means that the gradient is equal to 3. It's giving you the information here. It says that these lines are parallel. What does that mean? Well, it means the gradient of line 2 is also going to be 3. So the gradient of both lines is going to be 3. We can see here in this one that we can find the gradient there on that one, which means we can find that the line is going to have a gradient of 3. We're told that line 2 is parallel. Line 2 is parallel to line 1. That means they both have to have a gradient of 3. So how can we find the x-coordinate? What else will have this gradient? What else will have this gradient? Well, what is it? These are tangent lines. And what is the thing that we know about a tangent line? Is the tangent line and the derivative have the same gradient at the point of tangency. So the derivative is going to have the gradient of 3 at these 2 points. So what that means is we can say that the derivative needs to be 3. And we have the function there, x squared minus 8x plus 3. We want to know when is this derivative also going to be equal to 3. The quadratic equation is going to give us 2 solutions. We have to simplify this one if we wish to solve it, because it's not linear. So we rearrange it and we get x squared minus 8x. So then, on our calculator, get your calculator in your hand. We are going to put it into a function as ax squared plus bx plus c equals 0. What is the value of a in this equation? What is the value of a in this equation? A is equal to 1. What is the value of b? B is going to be negative 8. What is the value of c? C is going to be 0. So if you press menu on your calculator, algebra, number 3, and then polynomial tools, number 3, and number 1. So menu 331. Menu 331. It will say what degree is it? It's a second degree. And then we can type these in. 1, negative 8, and 0. And it will give you 2 solutions. So we see on the calculator that x is going to equal 0 or x is equal to 8. If you need help with that calculator routine, put your hand up now. I'll come round and help. Okay, so we've got our solution. We know that x is equal to 0 or 8. So which is the x-coordinate of line 2? Well, what we can do is we could sketch this. So the problem that, let me just move across, create a new page. Control, add page, let's add another graph page. So our function that we're looking at is x cubed. You don't have to do this, just follow me along on the screen. X cubed over 3 minus 4x squared plus 3x. So our function should look like this. And we've also got the linear function that we can add. We've got the linear function y equals 3x. So y equals 3x. We notice that it crosses here. So if this is crossing here, what is the x coordinate at which it crosses at? 0. So what is the x coordinate of line 2? What is the x coordinate of line 2? Which is the line I've drawn here? Is this line 2 or line 1? This is line 1. Where does line 1 tangent the curve? So where does line 2 tangent the curve? At -8. Is it -8 or was it 8 actually? I think I've written. It's 8, sorry. It says equals 8. All right. Okay, so 8 is our correct answer there. Let's have a go at this last problem. Actually, let me run through it straight away. Let me go straight into this one. So we've seen questions like this much earlier in the course where we have to make a couple of equations. So this type of a question, we need to make a couple of equations to solve the problem. We want to find the gradient of the normal to the curve of this curve. We know that at that point, it tangents at 2, 3. The gradient of the normal is -1/3. So we've got a few cryptic pieces of information here in which to find A and B. So here is our curve, y equals ax squared plus bx minus 10. What would be a good way to start? Our goal here is to find two equations. We want two equations in A and B in order to find it. So we've got two pieces of information. One is for each equation. We've got this piece of information here, and we've got this piece of information here. How does the 2, 4 relate to that equation? We can put the 2 as the x value. What about the y value? This equation tells us what any y value will be if you know the x value. Do we know the x value? Do we know the y value? We simplify that, we get 4 equals 4a plus 2b minus 10. We can simplify further if we want, but we don't need to. That's enough. As long as you get a linear equation in A and B, we can put it into the calculator later. So here now we have equation 1. That's the yellow piece of information. So the yellow piece of information leads us here. How about the green one? What is the -1/3? The gradient of what? Of the normal. So if the gradient of the normal is equal to -1/3, what is the gradient of the tangent? What is the derivative? What is the value of the derivative going to be? And at which x value? Key concept lesson number 1. The derivative's value is the same as the gradient of the tangent. So if the gradient of the tangent is 3, the derivative's value will be 3 at a particular point. Now, is it going to be at x equal 2 or x equal 4? 2. 4 is a y value. So what we need to do is we need to take the function y minus 10, differentiate dy dx. What is the derivative of this? 2ax
Plus B.
plus b. So what is the x value? What is the x value? 2. What is the derivative's value? 3. So this value here is coming from up there. This value here is coming through this sort of path like that. So now we have our second equation. Don't pack up yet. 3 equals 4a plus b. And this is our equation 2. So to get our answer, don't pack up yet. To get our answer, what we want to do is we want to make an equation system with these two. We've got one equation which is 4 equals 4a plus 2b minus 10, and 3 equals 3a plus b. Put this into your calculator now. Put your equation system into your calculator. Let me know what your answer is. I'll come around and check them when you're done, and then we can leave as our exit ticket. So we want to do menu 3-2, solve a system of equations. I like to change the variable to AB. You can keep it as x and y and just do a transposition of those if you wish. So it's 4 equals... if you haven't changed them, then yes. If you have changed them, then no.
Minus 10.
Minus 10? Who can give me the answers? What do we get? No.
Plus
Bon?
3 over 4, comma,
Bon?
in the middle. Minus 4.
Minus 4 and 15. Okay, we're finished there for today. I'll come around and help anyone.